So, welcome you all to today's LeetCode challenge. This is our day 287. The question we were solving today is 2984. Make lexicographically smallest array by swapping elements. The given question states that we have given a zero index array of positive integers, nums, and a positive integer limit. In one operation, we can choose any two indices I, j, and swap nums of I and nums of j if the absolute value is less than equals to the limit, and we have to return the lexicographically smallest array. Lexicographically smaller means the first element of array should always be less than the first element of another array. If the first element of both the arrays is same, then the second element is compared. Let us have a look on constraints. The constraints given are that nums.length will be maximized into 10 to the power 5. So we cannot write a solution for big O of n square because that will eventually give us a TLE. So we have to write something better than that. Let us clearly observe what could be done. We have given nums as this and limit 2. So if if we check one, if we check from which number this one can be swapped, is there any smaller number than this one in this array from which this one could be swapped? So we cannot find any. And for this 3, if there is any number in this array that can be swapped from this, and the resultant array should be lexicographically smaller. So if we check this 5 with this 3, so the absolute difference between these two is less than equals to the limit, which is 2 then, and so we can swap this 3 to 5, and this resultant array become 135. Now if we check our 9 and 8 grouping, so we can observe that we can swap this 8 to 9, so the resultant array should be 138589, and we cannot obtain a lexicographically smaller array than this could be the lexicographically smallest array within the given constraints to us. So first we have to observe that for every sorted pair of nums we have to maintain its indices as well. So let's code this and observe what could be the approach for us. First we have to maintain a pair which stores its val and indices. This is called pair because we have to store, basically we have to store as a pair of nums of I with its indices in original array. Now we declared the pair array using malloc size nums.size like this, nums.size or n, basically n. This nums.size could be n. Now after that we have to insert elements into this paired array. For every help of I, there could be two values. One is indices and second one is val. So this could be inserted using this like this. So this help will eventually take the nums of I with its original index present in nums. Now we have to sort the nums array using the inbuilt queue_sort. This is a custom comparator operator in queue_sort. We have to provide this. On what basis we have to store this help? So let us declare the custom comparator operator in C. This A and B will eventually receive a pair every time. So we have to typecast A and B to its original paired value first. Like this, we have to firstly typecast A into a pair and then its val. Now this will typecast it into a pair. So we are considering this as A, and this whole line means the value of A minus typecast this B into a paired first and then use its value like this. So this will sort our helping array like on basis of value. Now we have to declare our resultant array. This could be of n size. We have to declare this by dynamically because the returned array must be malloced and the caller may calls free for this. So we have to always allocate dynamically in C. We have to maintain a previous pointer that could store the previous value for every operation we will done. We also have to maintain a position array to check out what could be the best possible position for every pair we have. Now we start a loop from s equals to 0 and equals to 0 and we will move till e is less than equals to 9. Like s is pointing here and e is also pointing here. We move s in some condition when we want to move that, and we move e, and this loop will eventually terminate on the basis of e if e is outside the bound of the index. In this we store in position count of help of index 0, and we then store in previous variable the help of a dot val and increment our end pointer. We have to check if this end pointer could reach the last value, or this end pointer minus previous if in is greater than limit, then we achieve the condition where uh, the already sorted part could be done, means the grouping is done in this. So we have to sort our current position array using the qsort inbuilt, and the current sorted position array now is inserted into the resultant array. We only have to store help of s of values there and not the indices. Now we have to deallocate the memory for help and position array. Position array basically the helping array for us, and the position array will eventually group the store the group part together. And we have also make our return size pointed to n so that the caller may find what is the value for which the loop could be run for that particular case, and then we will return our final answer. Let us check if this is working fine or there could be any error in this. We made a little mistake here, spelling mistake in this. Yeah, this is running fine. Let us submit this and check. Yeah, it is running fine. So thank you so much guys for today's LeetCode challenge, and keep practicing and do subscribe. And if you like this video, please like, share and do subscribe. Thank you so much.